In this video, dear students, I am going to teach you about the formation of outer orbital octahedral complex. And for this reason, I have taken one example here. The example which I'll be teaching you is COF6 3 minus hexafluorido cobaltate. What is the oxidation number of cobalt? Let us see. Let us calculate. Cobalt's oxidation number we need to know, plus F minus. So oxidation number of fluorido is -1. They are 6 in number, so I can write -6 is equals to -3 total charges. So cobalt's oxidation number becomes +3. That means cobalt forms this complex in its +3 oxidation state. Now we'll follow the same valence bond theory steps which I have taught you in the previous video. So according to those steps, first of all we'll write the electronic configuration of cobalt. So its atomic number is 27. So its electronic configuration becomes, till argon it is 18, okay, then followed by 3D in the sequence of shells I am writing 3D 7 and 4s2. Got it? Now cobalt forms this complex in its +3 oxidation state, CO3 plus. So in this situation the configuration is argon 18. Now 3 electrons are to be removed, 2 from here and 1 from here, from 3D. So 3D gets 6 electrons and 4s becomes vacant, and then we have 4p vacant available orbital and 4d vacant available orbital. Alright, now I will make the orbital representation of 3D here. So 1, 2, 3, 4, 5. 5 orbitals. Now 4s, then 4p, and then we have 4d. Sorry, here again I have written 4p, 4d. Now in 3D it has 6 electrons. So 1, 2, 3, 4, 5, 6. 4s empty, 4p empty, and 4d empty. Now in this situation, when F minus ligand approaches cobalt 3 plus, that means on the approach of F minus, and if you remember in the previous video I gave you the hint or the knowledge of strong and weak ligands. So if you find out, then F minus is a weak ligand. So on the approach of this weak ligand, no pairing will take place because weak ligands can't bring about the pairing of the electrons. So situation remains as it is. So in this situation only F minus coordinates with the cobalt ion. So on the approach of F minus, when the formation of the complex COF6 3 minus takes place, then situation is like that. Of the cobalt central metal ion, argon 18, 3D contains 6 electrons and then these orbitals will undergo hybridization. So 4s, 4p and 4d, not 3d. From 4s 1 orbital, 4p 3 orbitals, and 4d we have 5 orbitals. Now the CN number, coordination number of cobalt is 6. That means it needs to have 6 hybridized orbitals. So the very next 6 hybridized orbitals are these many. They are 4 and 2 more. That means on the approach of F minus weak ligand, cobalt ion undergoes sp3d2 hybridization. Alright, now after this hybridization, the cobalt ion situation becomes CO3 plus is equals to argon 18 3D are as it is with the 6 electrons, 1, 2, 3, 4, 5 and 6. Now we have hybridized orbitals which are 6 in number. 6 in number. Alright. 1, 2, 3, 4, 5, 6 and they are sp3d2 hybridized orbitals. Now with these hybridized orbitals 6 F minus ligands they combine. So when they combine, they donate their lone pair to the CO3 plus. So on donating, I'll write separately the electrons of F minus. These hybridized orbitals, they become the electron pair acceptors. So this way, the bonding in CO3 plus and 6F minus is completed. Now after bonding, it is very, very clear that only outer orbitals are involved in the hybridization like NS, NP, ND. So this complex will be outer orbital complex. Now in this complex you can see there are large number of unpaired electrons. So due to the presence of large number of unpaired electrons, first and foremost this complex will be paramagnetic. And we can call it as high spin complex. I hope these steps are very clear to all of you. So this was the bonding in outer orbital octahedral complex. Now next we will see the bonding in the tetrahedral complex, and for the tetrahedral complex I will take example tetracarbonyl nickel. So first and foremost its oxidation number of nickel will calculate. Carbonyl oxidation number is 0, so nickel plus 4 into 0 is equals to 0. Alright. So nickel's oxidation state is 0. That means nickel forms this complex in its 0 oxidation state. So nickel's atomic number, I hope you all know, it is 28. 28 means till argon it is 18. And then we have 3d8 and 4s2. Got it? Dear students, now since it is forming this complex in its 0 oxidation state, that means in its ground state itself. So now on the approach of carbonyl as a ligand, and if you remember in the previous video I taught you that carbonyl is a strong ligand. Now under the influence of this strong ligand, the pairing of electrons will take place. Alright, so let's see. To show the pairing, I'll show the orbital diagram. In this case, nickel will be represented as its 3d. We have 8 electrons, so 5 orbitals. 3d and we have 4s orbital. Here 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. And 4s contains 2 electrons, and then we have empty 4p. Alright. Now here from 4s electrons they go to 3d and cause the pairing of the electrons. Alright. So after pairing of the electrons, the situation becomes argon 18, then we have 2, 3, 4, 5, 6, 7, 8 of this own orbital and 2 coming from 4s, and these electrons are getting paired. Now 4s becomes empty, 4s becomes empty and 4p is also empty. Now nickel has to form, its coordination number here is 4, that means nickel has to form 4 coordinate bonds with 4 carbonyl ligands. So these 4s, 4 orbital, 1 4s and 3 4p orbital will undergo hybridization. So after hybridization, The situation can be written as nickel, argon 18, 3D, all electrons are paired. You can see, and then we have 4 hybridized orbitals. They are sp3 hybridized orbitals, and this is 3D. Now when nickel combines with 4 carbonyl ligands, at that time these carbonyl ligands, they donate their pair of electrons to these hybridized orbitals. So this way nickel gets bonded via coordinate bond to 4 carbonyl ligands. Now since during the formation of this complex, only outermost orbitals are involved, so we can say that this complex is outer orbital complex. Okay, and since this does not contain any unpaired electrons, so we can say this complex is diamagnetic. Since its hybridization is sp3, so its geometry will be tetrahedral. I hope it is clear to all of you. So this was the formation of tetracarbonyl nickel. Now we will see the formation of a square planar complex. So for square planar complex, example which I will take will be NiCN whole 4 2 minus tetracyanidonickellate. Oxidation number of nickel will calculate. Nickel, I can say now minus 4 from 4Cn minus is equals to minus 2. So nickel forms this compound with its plus 2 oxidation state. Now nickel's ground state we have seen argon 18, and I hope you remember its atomic number is 28. Alright, argon 18, 3D8 and 4S2. So in the plus 2 oxidation state it forms compound. That means these 2 electrons from the outermost orbital will be lost when it changes into Ni2+. So argon 18 in Ni2+, argon 18, and then we have 3D with the 8 electrons and 5 orbitals. So 1, 2, 3, 4, 5, 6, 7, 8, 3D, 4S is empty and its 4P is also empty. Now on the approach of Cn minus ligand, and you all know very well that Cn minus is a strong ligand. So strong ligand causes the pairing of electrons, so these electrons will get paired up. So as a result, after the approach of Cn minus, the situation of Ni2+ will be argon 18, and then we have a 3D which was having 8 electrons in such a way that 1, 2, 3, 4, 5, 6, 7, 8. Now this 5th electron gets paired with its 8th electron. Alright, now making one 3D orbital vacant. Now 4s and 3 vacant 4p. Now under the influence of these Cn minus, we have got one 3D orbital vacant. Its Cn is 4, that means 4 empty orbitals it should have, which should undergo hybridization. So those 4 orbitals are 1 from 3D, 1 is this 4s and 2 from 4p. They will undergo a hybridization. So now after hybridization, Ni2+ will be argon 18. Now these are the 3D orbitals, 4 orbitals which did not take part in the hybridization with the paired electrons, and 4 orbitals dsp2 hybridized orbitals. which did not undergo hybridization. They are available. Now, this Ni2 plus combines with 4 Cn minus. Now, where Cn minus donates its lone pair with these hybridized to these hybridized orbitals. So, this way NiCn whole 4 2 minus is being formed. So, if you look at the complex, in the formation of the complex, n minus 1d orbital is involved. So, we can say this complex is inner orbital complex. Now, no unpaired electron is left. So, it is a diamagnetic complex. Clear? Since its hybridization is dsp2, so its geometry will be square planar.